The line of best fit is that line that we've been drawing through the middle of all the dots. It's approximating what would happen if this data was generalized with a line. The only thing we've learned about this year so far is lines, but there are also curves, and how we can determine which type of line, if you want a straight line or if you want a curve, is the best one to use. We're going to be using your calculators to determine the line of best fit. Okay, so to start this off, we have some data. The data is shown on the table on the left. We have 1, 4, 2, 6, 3, 7, 4, 8, and 5, 11. Write those down in your journal. Also make sure to title this part of your notes linear regression. We're going to graph those. So also draw a graph in your journal. We have the x's and the y's. And then I'm going to skip ahead and put all the dots on here. Alright, so now that we have these points on here, it really does look like they would all fit on a line, except for that one dot. But because that one dot is higher than all the others, we can't put a line that goes through those other ones. We have to make sure that it goes halfway through all the dots. As in, some of the dots are going to be above the line, some of the dots are going to be below the line, because each one of these dots is pulling the line either slightly up or slightly down. It's changing the slope. Each one of these ordered pairs here are changing the slope of our line of best fit. To see how exactly it's changing it, we're going to need a calculator. If you have a graphing calculator, you can follow those instructions right there. And if you don't, we're going to be using Desmos.com. And how we're going to use Desmos is we're going to push this plus sign, and we're going to make a table. That table is using x1s and y1s, and we're just going to put these numbers in here. So 1, 4, 2. Up top, you can see that it automatically graphed the dots for you. Oh, okay, there's the origin. It already put the dots on there for you, so Desmos is pretty cool for showing you the graph at the same time as you can put in your calculations. The next thing we're going to do is we're going to start to make an equation. We're going to try to do it like we've been doing in our warm-up, where we put y, but we have to be specific about the y. If we want the new equation to match the data points that we're putting in, you have to look at your data points, and it's called y1, y sub 1. So on your equation, you're going to put y sub 1. Sometimes if you just push y and the number 1, it'll automatically put the 1 in the right place. We want it to be in a little subscript. And then we're going to try to do slope-intercept form, but instead of putting an equal sign, for the calculator to know that we're using our scatterplot data, you have to put this squiggly line. For most of you, it'll be around the escape key on a keyboard, but on my iPad, I had to go to the keyboard layout, and then it was down at the bottom next to my bookmark key. So we have y is approximated as, we need m for slope, x, but because the x is coming from the table, we're going to put x1, and then we're going to put plus b. y1 is approximated to be the slope times x1 plus b. And then it gives us all of this stuff, and it even drew a line on the graph for you. It drew the line of best fit. And I think that one right there looks a whole lot like the one that I drew. Very close. Okay, so let's see what else our notes want us to do. Oh no, don't cancel. Get out of there. It wants us to write the line of best fit equation, and it wants us to write the correlation coefficient. So let's do the correlation coefficient first, because that's the easy part. The correlation coefficient is the letter R, and my R is 0.977. The correlation coefficient is the letter R. Make sure you're writing that down. The correlation coefficient is the letter R, and R for this data was 0.977. If your R is greater than 0.7, or if your R is less than negative 0.7, that's about a pretty good number to indicate that it's strong correlation. The highest that R can be, R's limit is 1. And then down here, if the R value is 1, then the line of best fit perfectly matches your data. That means it goes through every single one of the dots perfectly. If the R value is less than 1, that means that some of them are going to be a little bit off of the line, and the closer it gets to 0, that means that it's no correlation. Draw a little graph to show what a perfectly R equals 1 graph would look like. So if the R value is 1, your line should go through all of your dots. How are our dots trending? They're trending positively. The R value will also tell you if you have a positive trend or a negative trend, because this value can be negative. You can have positive R's or negative R's. R is going to be between -1 but less than +1. R lives between -1 and +1. Now finally, let's do the line of best fit, which is we tried to come up with an equation, and that equation is going to have to do with y, and it's going to be, in Desmos we have to put that approximation symbol, but we're going to say that it's equal to, even though yes, it really is an approximation, Desmos is correct, the slope. We're going to use the slope from Desmos, which is down at the bottom. It says m equals 1.6. Desmos calculated the best slope to match a linear graph with your data. The best slope was 1.6. The slope always multiplies to x, and then the best b to match our data is 2.4. So we're going to put plus 2.4. I got those numbers from right there down at the bottom on Desmos. So Desmos gave us the equation for that line that best matches your data, and it told you that on a scale from -1 to +1, with 1 being the best it can be, our line matches our data 0.977, which means it's pretty much perfect. On this, we also need to say, though, we circled our descriptions, but we need to write it down also. Our line strongly indicates a positive correlation, positive linear correlation. Because our R value is 0.977. In math, you don't just make statements, you make statements based off of facts. So you need to include your R value there. Okay. I now want you to try that again. Go to Desmos. You can either type over these old numbers, or you can just clear out the table and the equation. You're going to make a new table, and then after you make a new table, you're going to have to make a new equation. Y, not just Y, but Y1 is approximated as M x1 plus B. So you just need to put in your numbers into your table. It's going to give you the equation for the line of best fit. You're going to put the equation, and then you're going to put the R value, and then you're going to say it was strong or weak, it was negative or positive because of your R. You're going to put strength, direction, because R was blank. You can do that 3 times. After that, I just need you to practice interpreting what a correlation coefficient is. So after you do those 3 tables up above, the only other thing I need you to do today, besides your actual assignment, is to interpret these numbers as weak, strong, positive, negative. Remember, if R is small, if R is less than 0.7, or if R is greater than negative 0.7, which just means on a number line, if you have R and it's between 0.7 and negative 0.7, then that's going to be weak. If your R value is positive, then it's going to be a positive. This one's going to be a weak positive correlation. Some of the other ones will be a strong negative or weak negative. Okay, good luck on your assignment.